All right, ladies and gentlemen, we have a little bit of an interruption. But now that you have drawn out the orbit of the Earth and drawn a line from the sun directly across to the right, you're going to label that line as 0 degrees. We label this point as the 0 degree line. We're going to measure our angles counterclockwise around the orbit of the Earth. Our first angles are going to be measured from the sun to the Earth, and our second angles are going to be measured from the Earth to where Mars is observed. You're given data, and the first data point in each set, if you look carefully at that, you notice that the angle for the Earth to the sun and from Mars to the Earth on each of these is the same angle. This is at a time when the planet Mars is in what is called opposition. The sun, the Earth, and the Mars create a straight line from one to the other. So our first one that we're going to be marking off is point number 1, when the Earth is at 66.5 degrees from the sun. Remember, we're measuring from our 0 degree line. So we take our protractor. We're going to place the vertex on the sun, line up our 0 line along the 0 line, and come around and mark off a line that comes out to 66.5 degrees. And then we're going to use our straight edge. You can either use the protractor or a longer ruler, and draw a line out to the Earth's orbit, marking that, and then put the date next to it. From here, we're going to measure the angle to Mars from the Earth. Now, we already know that this point is in opposition, so we could just continue this straight on out. But let's do it the way it's meant to be done. And we line up our protractor with Earth being at the vertex. And then we follow it along. Remember, 0 is off to the right. And we come around. We find our 66.5, we put our dot, and we, again, continue our line. At this point, we actually don't know where along this line Mars will be found, but we know it will be found somewhere along that line. Now we're ready for our second point. For our second point, it shows that the Earth is at 22.5 degrees compared to the position of the sun. We take our protractor again, we line it up, 0 point to the right, and we come across to 22.5 degrees, and we mark that, and we make our line across, mark the position of the Earth at that time, and write the date next to it. In this case, it is October 16th, 1582. That's 687 days later than the first point we did. That was at 11/28/1580. Why is it 687 days later? Because Mars takes 687 days to go back to the same place. So it's going to be in the same place as it was for that first line that we made, but the Earth is in a different position. From this position, when they look out and find Mars, it is now at 107 degrees from the Earth. We again take our protractor, mark our vertex. 0 again will be to the right. And we come around and we find 107 degrees from the Earth. And we now draw a line from the Earth until it intersects with that first line. At this intersection point is where we mark our point number 1 in Mars orbit. That's our first point. There are 14 points to be plotted. So you probably want to make these lines in pencil and light so that you can erase them later, because as you go on, it gets to be very complicated when you see all these distractions. But you do want to mark the dates for the position of the Earth And of course, you need to mark Mars' orbit, since that is what our goal is to draw out the ellipse that Kepler was able to discover from looking at the orbit of Mars. That is what you need to do with all 14 points. We have just gone through number 1. Number 2, you will start off with 107 degrees from the Sun, Mars at 107 degrees from the Earth. Again, they're in opposition, so you could just draw one straight line through them. And then the Earth at 62.5 degrees from the Sun, and Mars at 144 degrees from the Earth. When you get all of your points, you're going to do your best to draw a nice, smooth, curved line through all of those points to represent the smooth orbit of Mars.